Welcome to the Virginia Education Center for Asphalt Technology. My name is David Lee. I'm with the Virginia Asphalt Association, and we're going to talk to you today about the equipment and laydown operations for the Asphalt Field Level 1 school. Our learning objectives for this module are to be able to identify the types of transverse joints. There are a lot of joints that occur when in a paving operation, transverse joints being one of those. We're going to talk about that in this module. We're going to become familiar with that startup and resuming and end of paving operations that occurs, whether it be at the end of the operation where you're finishing off the paving or you're stopping at the end of the day and picking up the next day. We're going to determine what's called an ACOT 1. We're going to talk to you about what that is associated with and why that was developed. And then we're going to recognize the steps in creating a longitudinal joint. So longitudinal joint construction is critical to the success of our pavement structures. So each and every one of these steps we're going to talk about during this module. So let's talk about transverse joint construction. Transverse joint construction can occur in many ways. Think about transverse joints. Obviously, it's where you start, you stop. It's perpendicular to your paving operation. Those can be a butt joint. They may very well be a taper joint. We're going to talk about tie-ins. You tie into an existing pavement structure. You may tie into an adjacent roadway. Your starting and stopping operations. Paving, you're going to resume paving at the beginning of the day or the next day. We're going to talk about those. And again, we're going to talk about exactly what does an ACOT 1 represent. So end of paving, let's talk about those. So at the end of the paving operation, when you're done at the end of the day, if you're milling, like is in the picture on your left, you'll have a mill joint right there. So that will actually be what's called a butt joint. So when you come up to that butt joint, you'll have a milled vertical face. If that's the end of the paving operation, like this is depicting, you'll pave right up to that and you'll have a tie-in right there at the end of the butt joint. There's also something called a tapered joint. So if you're tying into the existing pavement and you're tapering that down, if it's a temporary tie-in at the end of the paving, you may use something. In the old days, they used a lot of paper. They may have used roofing felt or something like that so that that joint could be easily removed the next day. But at the end of the day, you'll have a tapered joint because you didn't mill, so you have to have a taper, and we'll talk about this more later also. You have to have a taper so that the traffic that runs into it doesn't actually have that bump that you would have if you left a vertical joint or the butt joint that's on the left. Then we'll talk about tie-in. Let's talk about where you do a tie-in to the existing pavement. So when you're tying into the existing pavement, obviously it's going to require a fair amount of handwork. Your paver will come up, it'll actually pave up to the end of that joint. You'll tie into that joint, whether it be the existing pavement joint or you're tying into an adjacent roadway. You have to make sure that that's checked for straightness. You've got to be 1/4 of an inch and 10 feet. So you have to take a straight edge and actually check that tie-in to make sure you meet the requirements for the tie-in according with VDOT specifications. Again, you want to minimize handwork, but you do have to do a little bit of handwork to ensure that you get that tie-in such that it meets that straightness specification. So when you start up, or you resume paving the next day. We talked about a taper joint where you may have tapered it down. If you look at the picture on your left, you'll see where they tapered that down and they actually are now going back and they're taking that out. So they may use something like a jackhammer. For many, many years, jackhammers were used to create that vertical joint, and still some are today to remove that pavement from that joint. So you'll come in and you'll square that up. You may very well even use a bobcat milling head. So you'll come in and mill that section up back to that joint so that you can remove all that material, you remove the debris, and then you can start up your paving operations just like you did when you began the next day. Talked about tacking. Tacking is absolutely critical. You have to tack that transverse joint. So at the start of paving or when you start resume your paving operations on another day, you've got to make sure that you tack that joint, you tack it well. That transverse joint, if it's not done correctly and it's not tacked correctly, then it becomes a conduit for water to get into those cracks, and therefore it'll fall apart. It's an area where you may have a little bit of low density, so you need to be sure that you get that tacked properly. Again, just like I said a minute ago, you're going to have to hand rake that a little bit to make sure you get that tie-in done correctly. You have to meet that straightness specification. So make sure you do that carefully and don't get carried away with the raking or luting at the joint, but make sure you get it done such that it meets that straightness specification. Compacting that joint. So when you start that operation, you've got to compact the joint right there as you start off while it's still hot. There are many ways to do that. The picture on your left shows an ideal method where you don't have to worry about traffic, or at least you have traffic stopped. You can actually come across that with the roller parallel to the actual transverse joint, so you're riding directly on top of it. But you got to be careful, because you don't want to push that material away from that joint so that you wind up with a bump. So you've gone to a lot of work, you've placed it correctly, you've done the minimal amount of hand work that you need to do with luting, and then you come across and you use the roller to compact it. The last thing you do after you got it fully compacted again is ensure that you meet that straightness specification. It'll be checked with a 10-foot straight edge, and again, it has to meet that 1/4 inch in 10 feet. I talked to you about ACOT 1. What does ACOT stand for? ACOT stands for Asphalt Concrete Overlay Transition. So that is something that was developed a number of years ago, primarily because of our bridge structures. So when ACOT 1 was developed, one of the concerns that VDOT had was they're not allowed, or they don't want to, reduce that clearance that's under any of the bridges. They try to maintain whatever clearance is there for all of their bridge structures. So ACOT 1 was developed to work with that. So it's a function of posted speed. So if you think about it, you have to actually, to ensure that you maintain that clearance underneath a bridge, if you're placing an overlay on it, well, now you have to taper that down as you go under an underpass for a bridge, and taper back out on the other side so that you ensure you maintain the clearance. This ACOT 1 standard has certain criteria based on posted speed limit and the actual overlay thickness that you have that tells you exactly how to do that. It tells you how much you need to place, and then how much you need to taper, and how long that taper needs to be for each and every operation based on that speed limit and that overlay thickness. Within that ACOT 1, there's also minimum lengths for temporary transitions. So within that, you may very well be at the end of the day paving on an operation on an interstate. It tells you how long that transition has to be, and it's a function of the actual overlay thickness. So in ACOT 1, it says for every inch of overlay, it's required to have 3 foot of transition. So if you had 1.5 inches of an overlay, that means you need 4.5 feet of transition. So you can't just put a short transition in that's only 1 foot long. It has to actually transition out to that 4.5 feet if you've got 1.5 inch overlay. If you've got a 2-inch overlay, it's the same thing. It's required 3 feet for every inch, so 2 times 3 gives you 6. So in this case, for a 2-inch overlay, you need a minimum of a 6-foot transition. So again, let's talk about resuming paving operations. It's basically the same thing as you do as a startup operation. So when you began your operation in paving, you started with either a milled surface where you had a butt joint and you pulled off that butt joint, or you had to remove, in this case, now that you're resuming operations, you may actually have to remove the tapered joint that you had there, as we talked about earlier. That could be a paper, like a roofing felt. You may be using jackhammers or a milling machine to make sure that you get that tie-in done correctly. And again, it's critical that that be cleaned and you have a proper tack at that vertical face when you start off or you resume your operations each and every day. So it's very similar to a startup procedure as you did at the very beginning. You're just doing that at the beginning of each operation. When you come back out the next day, you're tying in and you're doing your proper startup operation. So let's talk about the longitudinal joints. Obviously, the longitudinal joint is just like it says. It's a longitudinal joint that goes down your pavement structure. It's going to occur when one lane of asphalt mix is placed adjacent to the previous asphalt mix. So if you've got a 2-lane segment that you're paving, you go down the road and you place one lift in one lane, and then the next day you come back and you place the lift on the other lane, it's going to create what's called a longitudinal joint. And it runs right down the middle between the 2 lanes that you just placed. There's some common terms that are used that you'll hear as you're going through the paving operations. You'll hear things such as The cold lane or the cold mat, that's the existing or the previous placed lane that's in your pavement. So that would be cold. It was placed, let's say, yesterday, and then you're coming back the next day, so that's the cold lane or the cold mat. Then there's the hot lane or the hot mat. That's the lane that you're placing today or that you're placing now. So that's the new one currently being placed, and it's going up against the cold lane typically. Then there's something called joint overlap. So when you're placing that, you have a longitudinal joint, as we've discussed. You're going to have a slight overlap there. That's the amount of overlap by the end gate of your paver onto that cold mat. So you're paving your hot mat adjacent to your cold mat. You have an end gate on your paver, and it actually overlaps that slightly. And there's another term called low density area. That's any location where the minimum desired compaction is not achieved. Everything that we do is to try to ensure that we don't get a low density area. But if you do, that's generally what they're called. They're called a low density area. Sometimes you may get those along a longitudinal joint. That's why we're discussing it here. If you do, you have to do things to try to correct that. Then you'll have extra material for compaction. That's that mix that's at that longitudinal joint to ensure you get compaction at that joint. So you're trying to get just a little bit of extra material so that you can force your asphalt down into the joint and make sure that you get good compaction and don't wind up with a low density area at your longitudinal joint. Staggered joints. So when you're doing a longitudinal joint again, if you think about it and you're constructing a pavement and you went out and you had to build 3 different lifts. You have a base lift of asphalt, then you have an intermediate lift of asphalt, and then you have a surface lift of asphalt. If you are not careful and you place those exactly the same from bottom to top, what you wind up with is a joint that actually transmits from the very top of your pavement structure all the way to the bottom. We don't want that. What we want is those joints to be staggered, and they need to be staggered a minimum of 6 inches. So when you place your base asphalt lift, and then you come up the next lift to place your intermediate lift, the joint, that longitudinal joint, needs to be offset or staggered by 6 inches. So now that joint will be staggered off, just like this slide depicts. You'll come back with your surface and you'll stagger it again. Now you're putting your other one 6 inches away from the one below that so that you don't wind up with a conduit from the very top to the very bottom of your pavement structures. All those are staggered, and you can ensure that that pavement structure is capable of maintaining its condition for hopefully a long life. Talked to you a minute ago about overlap. Along that longitudinal joint, when you're paving, you'll see in this case, that's the extension we're talking about that's overlapping the existing lane or that cold lane or cold mat. So the overlap of that paver extension sits about 1 to 1.5 inches onto that adjacent lane. And you can't set that directly at the joint because there's just no way to actually match that perfectly, number one. Number two, you need that additional material we talked about to ensure you get good compaction at the joint. So if you place that well, you get that slight extension of 1 to 1.5 inches over the existing lane, you got a better chance with that overlap. If you look at the slide on the right, you'll see that because you have that slightly more material that sits at that joint, you've pushed that material into that joint, it will actually be slightly higher than the adjacent joint, about 1/10 of an inch. That doesn't create any problems whatsoever. It doesn't cause any problems for the traffic. And you want that because that ensures that you get the proper compaction at the longitudinal joint. So that is the reason why you do that slight extension and you ensure you get some additional material at the longitudinal joint. There are some things that are some joint construction devices. VDOT does not require a contractor to use a joint construction device. However, there are some out there that can be used. There's several different types and techniques that are used in varying degrees of success. Some states actually around the country actually require certain types of joints. There's something called a notched wedge joint that actually, just like it says, it has a slight notch in it so that you don't have that vertical face. There's a cutting wheel. Sometimes what they'll actually require you to do is actually come back out where we were talking about and cut off a few inches of that pavement structure and remove it because it's low density, and then come back and pave again up against your new cut section. Then there's something called a joint maker that actually is a mechanical device that helps you create a joint. And then lastly, there's an edge restraining device. In some instances, for an unrestrained edge, you'll have an edge restraining device that helps you get compaction along that edge. But I'll point out again, VDOT does not require a joint construction device to be used. They do have longitudinal joint density requirements. So when you go out and construct a joint, you have to ensure you meet those longitudinal density joint requirements. We'll talk about that in another module. But again, there are multiple ways to create a joint. That staggered operation that we required is necessary, but one of these methods can be used, but is not required. Joint adhesion. We've talked about it a lot. We need to have a good sealed joint, whether it be a longitudinal joint or even if it's a transverse joint. Those need to be such that we get long-term performance out of our pavement structures. We don't want that to fail because of poor bond. However, there are multiple ways to achieve that. In some cases, you have some people that'll heat that side. So they'll actually take an infrared heater, they'll heat the cold side so that you can get a little bit of more bond with that layer, and then place the adjacent layer beside it so that you have hot against hot and hopefully get a tight joint. Then there's things called a cold side adhesive material. There are a number of manufacturers of these types of adhesive materials that are used. Sometimes they're made of rubber-based and polymer-based materials. And they actually provide an adhesive to that longitudinal joint so that when you place a hot mat against the cold mat, you get a sealed joint. But lastly, again, VDOT requires number 3, which is coat the cold side with a heavy tack coat. In the tack coat module, it actually talks about this, where we tack that joint very heavily, and there's a number of procedures that are required, but you have to ensure that you get a good tack at these joints, and that's what VDOT requires you to do in all of their construction work. That sealant that's placed there, the tack, the emulsion, actually will pull into that joint. It'll seal the joint with water, and it'll actually sometimes absorb, because you put an extra heavy amount at the joint, it'll actually absorb into your pavement structure a little bit and actually provide a nice seal. As long as you get good compaction and you construct it correctly, they seem to perform very well. Joint overlap. We've talked about this a couple of times. That end gate's got to sit over on that cold mat. When you get that cold mat and you get that 1 to 1.5 inch overlap on that end gate for the cold mat, you get that slight excess material that we talked about. If you have the opportunity and you can take that lute and you can bump that. You don't try to push that material. You'll notice in this picture, you don't see them actually raking that material out onto the actual pavement structure. They're just taking that lute and slightly bumping that joint so that that extra material is actually sitting on top of the joint. Then you'll come back and roll it, and you'll actually get a really tight joint. That's if you have the opportunity to be able to bump that with the lute. Many instances, traffic won't allow you to do that. But again, if you can, you're trying to get that excess material at the joint so that when you come back to do your compaction, you actually push that material into that joint. You'll have that slight 1/10 rise in the adjacent layer, and you'll get good compaction and create a nice tight joint. Surface joint location. We talked about ensuring you have that staggered joint with the layers down below that, but you also have requirements for the surface joint. So that joint itself has a number of things that require it to be sometimes offset. The picture you see on the left, you'll see that you actually have a snow plowable marker. In this case, that joint needs to be offset from that snow plowable marker. You'd say, why? Well, if you think about it, that is again where you have the potential for the lowest density. You actually have a difficult time compaction that. We do all these requirements, ensuring we get the best we possibly can. But if you put that snow plowable marker like you see in the picture adjacent to it, right on the joint or right next to that joint, you've now put it in the most vulnerable place it can possibly be. And for multiple reasons you don't want to do that, but the biggest reason is now you probably aren't going to get a good bond with that snow plowable marker, and there's a good chance it'll come out and then it won't perform. You also have the opportunity now of creating more problems, and therefore that joint won't perform well and you have low density areas. But then lastly, you also have to make sure you offset that joint so that you don't wind up right smack in the middle of the road where the line markings are. Because if you put the joint right where the line markings are, and you want to come back and do some maintenance later on, because again, we talk about crack sealing. If you crack seal that longitudinal joint and it's sitting right where the line markings are, you can see in the far picture on the right, now that crack sealant's gone right on top of the line markings. So in this case, not only have you now eliminated the line markings, but now you have to create a problem because many line marking materials don't stick to that crack sealing. So depending on what type of line marking material you need, and in the specific instance on that specific roadway, you've created another problem to where now that line marking might have to be offset when you come back and restripe. So that surface joint location is critical. It has to be offset from the center line markings, and it has to be offset from these snow plowable type markers. So ensure that you get all those placed, and it takes some time to make sure that when you're doing a roadway and you're laying it out, that you've got that longitudinal joint set in the right location. Want to make sure you have the opportunity. You have some other materials that are available to you through your Canvas in Germana. There's an online subject matter expert. In this case, it's called Best Paving Practices. It's by Todd Mansell with Caterpillar Paving. Please take the time to go out and watch this video. Todd does a fantastic job of talking about various things that can be done that go beyond what this module has actually talked about. It gives you a lot of information, and I think you should take the time, and hopefully you will take the time to go out and watch that. In summary, construct those transverse joints smoothly. As we pointed out early on, there's a straightness specification VDOT requires. So when you're building a transverse joint, at the beginning and the ending of your operations, it must meet that straightness requirement, and it must meet that for each and every joint. So all those transverse joints must be smooth. When you construct your longitudinal joints, make sure they're in the right location and that you have enough material to get full compaction and the proper density at those longitudinal joints, and VDOT has requirements for longitudinal joint density. So take the time to look for those and ensure that you can get good quality compaction for all those longitudinal joints. That's the end of this module. If you have any questions, please see your proctor and enjoy.